prevention is something, it is a practice to protect the assets or resource before the threat come. Inside that we have seen three tasks, right? Task number one was we have to assess the asset. We have to assess the asset, and after that we need to find out the vulnerabilities, and then we have to apply the measures. We have to apply the security resources on it so that we can protect it out. These all are the three tasks that we have seen. Once after seeing this task under the prevention, we started to understand the strategy. What strategy we are following to protect the resources or assets under the prevention? What strategy we are following? So we are following a layered security strategy. Layered security strategy we are following. So first layer we have seen, it was perimeter layer. So how the AWS is protecting that perimeter layer, basically the data center, that we have seen. That was the first one, perimeter. Second one was your um, let me change. Yeah, second one was your network layer. This was your network hardening. We have done with this network hardening. And then third layer we have seen system hardening. And now we are going to discuss about the fourth one, which is data layer. Layer is nothing here. Layer is something like step by step you are going to protect. First this layer, second this layer, and then third, and then fourth. So in network, we have seen how to find out the vulnerability, how to find out the assets, and how to apply the measures like firewall and IDS, IPS and all. Like in the systems also, we have used AWS System Manager. By that we can find out which systems are above the baseline, which systems are below the baseline, that we have checked, and after that we have applied some of patches here. Now we are entering into the data layer. So here we are calling it as a data security. This is what we have covered, and from here we will start the data security. So if you see what we are going to learn under the data security, so first we will be learning about the encryption techniques, which will help. Basically the encryption technique will help us to protect our data. You can call it what it will protect. It will protect confidentiality. If you see the goal of security goal of security, so it was CIA triad, and this triad was confidentiality, integrity and availability. So by using encryption technique, it will help us to protect the confidentiality. And describing hazing will ensure the data integrity. Means data integrity means this I part. Hash value used to be there. We used to call MD, message digest value, or you will be having a hash value. By using that hash value, you will verify whether the actual data which you are using, that is the same, or it has been altered in the middle. And then in the last, we will be talking about the availability. Means we will be discussing about different types of access control. There are two types. One is your discretionary and second one is your role based. So this will be our agenda basically. So now we'll be starting one by one. So guys, again, as you can see the picture, these all are the security life cycle phases. And in security life cycle, there are four phases. The phase number one is prevention, and we are learning the prevention only. Under the prevention, we have completed networking system, and right now we are doing the data security. Sorry, prevention is something, it is the first line of defense, and remaining things will be seen later, like if prevention fail, then detection and response and analysis you will be doing in future. This is the CIA triad, and you have to ensure the confidentiality, integrity, and availability of your assets. Confidentiality stands for whether the data is protected to prevent unauthorized access. It is confidentiality. Integrity is all about the data is the originality of the data is maintained or not. So originality should get maintained. It means that you are maintaining integrity. Availability means whether the authorized user is able to access whenever he wants to access. That is, see, that was CIA triad only. Now when we talk about protection of data, so there are two type of data we do have. One we used to call data in motion, and one we used to call data at rest. So the data which resides in our computer, the data which resides in our computer, that we can call data at rest. Basically in our hard disk or in our SSD, wherever we are storing the data, that data we will be calling it as a data at rest. And data in motion means, let's say if you are downloading something from internet, so data will travel and come, so that is considered as a data in motion. So for example, you need to download this data, this is data for example, or you can say this is the server where this data 11111000 and 000111, these all are the data, this data and this data which are here. Now through the internet you started to download. So once you got the data, it is changing. Here you can see this data is different, this data is different, this data is different, this data is different. So when the data is into motion, data should not change, data should be the same. That you will check it by using the hash technique, and it comes under the integrity as well. It comes under the integrity of the data, and here basically it will reside in the computer system directly. So now what technique basically we are going to use to protect the data? So when we are talking about the data, guys, so either it is on premises or it is cloud. If it is data, then in the on premises also it will be responsibility of customer or owner, and in the cloud also it will be responsibility of customer and owner. So you need to be very precise, you need to be very precise whenever you are accessing the data using the internet. So moreover, if you need to protect the data, what all are the techniques that has been given to you? What all are the techniques which are available to protect the data? So the first technique is cryptography and encryption. Cryptography is made up of two words, crypto and graphy. Crypto means hiding and graphy means text or graph, you can say. It means that you are going to hide something behind the text, or you are going to change the text so that nobody can understand. And this basically encapsulate under the encryption. It means that encryption comes under the cryptography. Cryptography is you can say it is a encryption is a technique. Encryption is a technique. It comes under the same techniques. It comes under the cryptography only, means hiding the text kind of. So encryption is a technique which we'll be using to complete the cryptography task. Moving further, see, this is the cryptography. In cryptography, as you can see, it is having the principles and techniques for providing data security, including confidentiality and data integrity. When we are talking about it is a principle and technique for providing data security. So what technique? What this technique is? This technique may be your encryption, right? So now the encryption is the process of using a code called a cipher to turn readable data into unreadable data. And after that, you can decrypt the data and you can read. For example, let's say, for example, if this is your data or message, you can say, this is the data. We used to call it AWS rocks. This is the message or data. In this message, basically, we are going to encrypt by using some keys. That key will be coming in future. By using a key, we are going to encrypt. Now, this AWS rocks has been changed into QVDTI, something like unreadable format. So if any user will come here to check it whether what exactly it is, so they will not understand. They will not understand what exactly it is. But if the same person is encrypting here, and if the same person is decrypting it, he can come to know this is AWS rocks. This is AWS rocks. Right? So encryption is the method of converting plain text. We will be able to understand like this. Encryption is the method. Encryption is the method of converting plain text means readable text to unreadable text, which is ciphertext.
Ciphertext.
Right? And for doing this, it will use some algorithms and keys also. It uses some algorithm. We'll be discussing about that algorithm as well. So, and it is encryption. Once we used to call decryption, it means that it will convert from ciphertext to again plain text. So you will be doing encryption to hide, and you will do description. What do we call decryption to unhide, you can say, to show it, right? So this is what we do have here. And in the same, it is telling us there is a key basically, and this key, as you can see, a key is a series of number and letter that the algorithm uses. So algorithm, or you can say a small concept will be here. One small concept will be here, algorithm. Algorithm, you can say it is a mathematical program. Algorithm is a mathematical programming that we are applying to this message. Who will apply this algorithm? A key. A key will have a series of number or letter that the algorithm uses. So this algorithm basically using this key to encrypt. See, using this key, it is encrypting this message. You can say a combination of keys plus algo. Both will be responsible to do the encryption and decryption. Right? Here in this case, only the key owner can read and see the data. Can encrypt and decrypt, and he can see the data also, what exactly it is. So there is a question, what data must be encrypted to stay secure? Now it's up to you what exactly you want to secure. So when this question is coming, you will be able to encrypt a folder, you will be able to encrypt a file, you will be able to encrypt a drive, you will be able to encrypt a complete storage, means you will be able to encrypt a volume, so many things, whatever it is related to storage, you will be able to encrypt. Moving further, what is the practical use of it? So as I've told you the example, like you can encrypt your file system, you can encrypt your drive also, computer to computer instant messaging and secure mail. For that purpose you can use secure socket layer and Kerberos. This is again a protocol that we are using to protect the traveling data, the data which is into the motion. So by using this protocol, you will protect it, and in that protocol also we are using encryption. So when your data is at rest, how will you do the encryption? We used to call file system encryption. You can use NTFS, we used to call window new technology file system. And by using NTFS, you can encrypt a single file or an entire set of files in the Windows. If you need to encrypt entire drive, then you have to download few tools like BitLocker or VeraCrypt. These all are the free and open source drive encryption. This you can use, and you can encrypt your drive also. I'll show you one by one. How NTFS encrypt, how to encrypt a file using NTFS. See, these all are the steps that has been given to you. You can test it out. So in Windows, basically, let's say you will browse the file or folder which you need to protect. You have to go into properties. Under the attributes, you have to click on advanced, and then a new window will open or pop up. You have to, in the compress or encrypt attribute section, you have to check the box encrypt content to secure the data, and you have to click OK. And now how to enable and disable? This has been given here. You can just go back to this uh, option and you will be able to disable and enable. For example, let's say in my computer, sorry, let's say this Android folder I want to encrypt. So I'll just right click and I'll go to properties, and then I'll go to security and I'll click on advanced, and here it was telling somewhere we will be getting the encryption option, auditing effective access. Let me check it again. Attributes, advanced. In attributes there is advanced. Are you able to see, guys, this folder properties which I'm trying to show you? This folder is visible, this folder.
Yes, sir.
Sorry, let's click on properties once again, and it is
Advance.
telling us advanced, and then under the advanced attributes it is just saying compress and encryption. Here, encrypt content to secure the data. This is not enable, we have to enable. This is not enable, you have to enable. See, this is the feature basically you can do. It is a matter of one small setting that you can do. Generally people used to do the encryption by using NTFS. It is a very short and simple. If you need to do with the complete drive, then you can use BitLocker and VeraCrypt. These all are the solutions that we can see here. BitLocker, sorry, this is basically BitLocker. We can see in the Wikipedia. This is BitLocker. It's a full volume encryption feature. It will encrypt your full drive, right? You can download it from internet. It is open source. And the VeraCrypt is also there. VeraCrypt versus BitLocker is coming, but VeraCrypt, it is completely open source, so you can even download and you can start using it. This will again, encrypt your drive. I'll show you the lab in AWS directly, how to do in the AWS. This is happening once the data is into rest. When the data will come into the motion, guys, then the time we are using SSL TLS protocol. This protocol is used to secure the data which are being transmitted across the wire. And when we are using HTTP, if you are adding yes, and this yes means it is SSL, and the TLS is successor to SSL. So you can say this yes means TLS now. And Kerberos is an encryption technology which we are using to encrypt all communication between two devices. IPsec also, we do have IP security. Basically, if you do have VPN, in VPN we are using this IP security. This is again a protocol, and it is the component of IPv version 6 that is borrowed for use with the IPv version 4. Both IP provides the logical connection between network devices, right? That is nothing but VPN, and you will be using IPsec to secure the tunnel. If you are accessing something, let's say this is one network, this is another network. From here, if you need to access some data, A wants to access some data which is present in yes. So this area we used to call it tunnel. So in this tunnel, if you need to protect, because we know how to protect the data at source, at destination, both place, both are computer, but the data which is into tunnel, which is moving, which is in motion, how to protect this data. So for that only we are using IPsec, IP security, and it is a protocol. Basically it also use the concept of encryption, and it will protect. We do have instant messaging or secure mail. So again here we are using some of uh, mail extensions like secure multi-purpose internet mail extension, which is MIME, and PGP also, which is pretty good privacy. These all are the two protocol which we are using to secure the emails communication. Now we'll be moving up in somewhat more detailed manner of your encryption. So uses of encryption. Basically, there will be one mathematical program that we used to call algorithms, that is only encrypt and decrypt your data. And a secret key will be also there that will ensure that only the key owner can encrypt and decrypt the data. So there are two things. One is your algorithm, and second one is your key. So by using the algorithm, we are converting it. Means if we are owner, then we can convert into the ciphertext. Later on, we being the owner, if we want to give somebody, let's say user A, so if I am sharing this data, I'll not share the algorithm, I'll share the data with the key also. So if this person will get the key, he will be able to decrypt it. So encryption, basically it is of three type. We used to call symmetric encryption, asymmetric encryption, and hybrid encryption. And these three types of encryption is very easy to understand. When we talk about symmetric encryption, you can say here you are using only one key to encrypt and the same key to decrypt. In symmetric encryption, you will be using only one key for encrypting the data and the same key for decrypting the data. So it is less safer. But if you go to asymmetric, it will use two key. One key to encrypt the data and second key to decrypt the data. So this will be using two key. When we talk about hybrid, in hybrid we are using both. When we say combination of symmetric plus asymmetric encryption is nothing but hybrid encryption. So this encryption is telling the message which we are forwarding, it is confidential, right? So here the message will come, you will encrypt this message by using a secret key, and this will be into this format, and after that the secret key will be shared to the destination end, and the destination end user will try to decrypt and try to read the message what exactly it has been written. Let's say here There are two user A and user B. User A wants to say hello to user B. He wants to send hello to user B. Now this message will be encrypted here by using the algorithm and this security secret key. So what will happen? This secret key plus algorithm will convert this hello into this format. And this is nothing but ciphertext that we can say it is the encrypted message. Once the scripted message will be delivered to the B, this message will be delivered to the B. Now B will use the same key. This key was here. Now this key will be coming here because A is sending that key also. So by using this key, this user B will decrypt this message and he will read this is nothing but hello. The process is very simple. And here we are using an algorithm called AES. This is the standard basically. Inside that standard the algorithm comes. So here we are using one US National Institute of Standard and Technology. So this standard basically we were using before and it replaces the previous triple data encryption algorithm. 3 DES algorithm has been replaced by AES. This is nothing but algorithm only, you can say advanced encryption standard. The AES has a 3 fixed 128-bit block cipher with cryptographic key size of 128 bits, 192 bits, 256 bit. Basically when we are talking about converting the plain text to any cipher text which will be unreadable, so it will not convert randomly. It will be having some concept of conversion, and that will be there into your algorithm. And this algorithm which we are seeing AES, it is having certain feature, right? Like cryptographic key size, and there is 3 different cryptographic key size we do have here. And a block cipher is a key and algorithm that are supplied to a block of data immediately. So basically it is nothing but guys, it is an algorithm which will change your plain text into ciphertext. For example, Amazon EFS uses AES 256, this one, AES 256 encryption algorithm to encrypt data at rest. We do have IDEA also, International Data Encryption Algorithm. This is patented in Switzerland and it is free for non-commercial use. And it uses a block cipher with 128 bit. We do have trophies also, TLS, SSL. We all are having these basically these 4 uh, algorithms we are using to convert the plain text into ciphertext under the symmetric encryption. Moving further, here we do have asymmetric encryption. So everything will be the same, but here 2 different keys we will be using. If let's say if B is requesting to get the hello message or B is sending something to A is let's say server. So if B is requesting for some message or A is sending the same hello message, so it will get encrypted by using this public key. It will convert into ciphertext, and now this user B will be having different key to decrypt the data. So whenever we are creating the EC2 instance guys, so you will be creating the key pair there, right? Sorry, in EC2 instance we are creating key pair. In key pair, once we are creating the private key pair, at the same time public is also getting created. Public is there with AWS, private is there with us. Once AWS creates any password, The same password travels to us, and the same password, if we need to decrypt, we are using this private key file to decrypt the password. You might have done it multiple times when we were using the Windows virtual machine. Is it clear, guys?
Yes, sir.
So what all are the algorithms we are using in asymmetric? We are using Reves, Samir, Edelman, which is RSA, and Diffie-Hellman algorithm. We are using to exchange method of cryptographic keys, and we do have LGAML and SSL TLS both. Means SSL we are, or TLS you can say, or SSL. This we are using into both. Either it's a asymmetric or it's a symmetric or hybrid. All the way we are using TLS SSL algorithm now in the when the data is into the motion. That's why, you know, right now when we are using HTTP, it comes as a HTTPS, just because of this. Here we can do the comparison. Encryption, the comparison between symmetric and asymmetric. Encryption, it is fast and straightforward. It is quite complex and time consuming. Process speed is faster of symmetric. Asymmetric is slower. Keys, one keys. Here two keys you will be using. Level of security is extremely secure. The risk of compromise if the shared key is lost. It provides additional security services. The key is not shared. Manageability become complex with more keys, but here it will be easy. It will help us with the confidentiality. Symmetric will help us only with the confidentiality, whereas asymmetric will help us into non-repudiation and authentication both, and some other stuff. When we say non-repudiation, guys, so what is the meaning of non-repudiation? Let's say if I tell you I am sending an email to you. Let's say Mr. A is there. I want to send an email to Mr. A. Mr. A has received this email. He has received this email and it is there here. It is here. Now Mr. A will delete this email and he will say, I did not receive the email. But I'll go in my sent email, sent option. I can check it out there. The email has sent. It means that non-repudiation means if you have shared something and you are confident on it, so honestly if it has been received by someone on the other end, so he should accept like, yeah, this was the case and this is the data which I have received. So this concept comes under non-repudiation. Authentication, you all know, something you have to prove that you are the actual user. And moving further, hybrid encryption. Hybrid encryption, by seeing this picture easily you can understand. Sorry. There are two persons, John and Sophia. John wants to send hello message to Sophia. Today is Valentine Day, so John will send happy Valentine Day to Sophia. Along with this hello also he can send. Right? So once John will send, message will get encrypted by using a secret key. Right? By using a secret key. This is the encrypted. This is the message has been encrypted, and here keys, the secret keys whatever you have used, now you will be using Sophia's key. John will use Sophia public key to encrypt this secret key. Means hybrid means, let's say uh, John John he has encrypted this message hello with a key called secret key. Okay, with a key called secret key. I'll just repeat it again. So John is sending hello message to Sophia. For that, John has encrypted this message by using this secret key. So the message has been encrypted here. Now in the step number 3, the secret key which has been used by John, this secret key will get encrypted. Again, this secret key, now we are encrypting, we have encrypted the data, but here secret key also we are going to encrypt. But how will you encrypt? By using Sophia's public key. You will encrypt the keys. Once you'll encrypt the keys, this is the encrypted keys. So this is encrypted message, this is encrypted keys. Now this will pass here. The encrypted message will come up here. Once the message will received, then Sophia will use the same. Sophia will use private key to decrypt the access. So what do we call secret key? Secret key. Secret key. First of all, Sophia will decrypt the encrypted key which has been shared, this key. Sophia will decrypt it by using her private IP. Once the private key will be used here to decrypt, then now you do have to decrypt this message, right? You will decrypt it. So easily you can encrypt and decrypt here. Now why it is hybrid? Because when John is encrypting the message hello by using a secret key, this process is a symmetric. Till here it is symmetric. Are you getting my point or not, guys? Are you able to understand what I am speaking?
Yes, sir.
Everybody, can you respond, please?
Yes, sir. Yes.
Yes, sir.
All right. So uh, this is this part is symmetric. This part will be asymmetric. Again, this part will be asymmetric, and then Sophia will use the secret key to decrypt the message. That part will be symmetric. So they might have mentioned somewhere, it seems. Sorry. They did not mention, but they have written here line by line what is happening. John wants to send message hello securely to Sophia. John uses secret key to encrypt the message into this. This part is symmetric encryption, right? And now John will use Sophia private key to encrypt the secret keys also. This will become asymmetric encryption. And then the encrypted message and encrypted secret key will send to the Sophia, are getting sent to the Sophia, and Sophia will use her private key to decrypt the encrypted keys. This part will become the asymmetric, and by using that decrypted secret keys, now Sophia will decrypt the message. This is symmetric one, right? So this is what encryption we do have. Now we are coming into the cloud. Like what all are the AWS services which are helping us into encryption and cryptography. So there are two services of AWS that has been introduced here. One is Cloud HSM and second is Cloud KMS. First of all, you need to understand what is HSM, what is the full form of it. So it is cloud based hardware security module. Cloud based hardware security module, which we used to call Cloud HSM, hardware security module. So by using this Cloud HSM, you will be able to generate and use your own encrypted keys on the AWS. If you need to create your own encrypted keys here, you will use Cloud HSM. And with KMS, you can also create and manage cryptographic keys and control you can control those key across wide range of AWS services in your application. So here in KMS, guys, you can create the keys and you can use directly in your application. So we will be using KMS here, and there is a difference that has been given. AWS Cloud HSM and KMS. It is fully managed. Fully managed means who is managing? AWS is managing. It is a service that primarily intended to support customer managed applications that are specifically or specially designed to use HSM for compliance obligation. It is again fully managed. Basically, if you are taking something hardware specifically in the cloud, that time you can use this. Rather than remaining things, for remaining things, you can use KMS. It is again integrated with other AWS services, and you can store keys in the default key store, and you can connect further to the cloud HSM also. So this was the part under the confidentiality. Now integrity. Now we are going to start with integrity. So integrity is the method to check or to ensure whether the data is modified, or you should ensure that data should not modify. Data should not modify in the middle. Data should not alter in the middle. Data should not get corrupt in the middle, or data should not corrupt. Right? So these should not happen to the data. For that, who will ensure? Integrity. Integrity is the method to ensure the originality of the data. For that, what technique we are using? We are using hashing technique to ensure the integrity of the data. So how this hashing works? How this data integrity works? So as you can see, data integrity means ensuring that the data remains accurate, consistent when it is stored or it is traveling through the network. Data should not be corrupted or tampered. The data should be the same which has been sent by somebody and which has been received by someone, right? And here we are using a hash mechanism to ensure the data should be the same. So here hashing and encryption, two different method or process we do have. So let's say when we talk about hashing, hashing is one-way encryption to create a signature of the file. In terms of encryption, if we speak about hashing, hashing is one-way encryption so that you can create the signature of the file. As in the Linux we have used the hash value, hash value. So hashing is used to ensure data integrity. Basically, a hash function will generate a unique hash value, or a hash function will generate a value. That value is only hash value, or message digest value we used to call MD value, from the content of a file or message. And then the recipients of the file or message can use the hash value to verify that the content has not changed during transit. For example, this is the file we are going to transfer from here to here, or from web server to this client machine. So this file, if we are transferring, first of all, there will be one algorithm which will use to generate the hash value, and this hash you will also download. Now once the file will come here, and this is the downloaded hash, you will match. If it is same, you can say the integrity is maintained. Sorry. Now we are coming into the permission, guys. Permission. It comes under accounting. Permission of principle of permissions. How basically we are assigning the permissions. So basically, what is the use of permission? Permission basically we are giving to any entity, either it can be user or any other resource or service. So giving permission to any user, meaning is we are allowing the access of the resource to that user. Means subjects are granted permission over objects, right? So let's suppose this is your object and users will become here subject. So if you see this sentence, subjects are granted means user A, user B, user C, they are granted the permission of object. And permissions are used to allow explicit access to a resource. And there are two types of permissions we do have. We used to call discretionary and role based. Generally we are using role based more nowadays, but here you will be able to understand the differences between both of them. Let's say when we say discretionary access control, discretionary, discrete, let's say if I write discrete. Discrete means what, guys? What is the meaning of discrete? Discrete means unique. You can say unique in the sample volume. Unique in sample volume. Now what is sample? Let's say you do have the population. Population is nothing but your entire data. Your entire data. Out of your entire data, you have selected some data only, few data or few resource. In this resource, in this data, we are talking about discrete means uniqueness should be there. So when we are saying discretionary access control, DAC, it means that this is the owner and this is the file. Now there is a user A, let's say. This owner can say this file can be read by this user A, or this user A can read, write, or he can have the full enough control. Who will decide? This owner will decide here. This is discretionary. Generally in individual cases, if you need to assign the permissions to the users, then you will be using discrete. For example, decentralized access. Decentralized access means if the access is not getting provided to everybody from a central location, from different locations we are providing the access. In that case, we have to use discretionary access control. Different user will be having different permissions. We do have access control list, means who can read and who can write, who can have full control. We do have access control entries, ACEs, auditing and dynamic access control. So these all are basically the properties of discretionary access control. Sorry. Now role based access control. So here you will create a role. Here you will create a role. Now in this role you will assign the permission. You will assign the permission to this role. Permission to this role. Now this role directly you can associate with one assets, right? And this role can be used by now these entire groups. The actual scenario you will be able to understand. For example, let's say I'll repeat this part again. This is role. In this role we do have full control. In this role we do have read and write. Now this is the role group 1 user. You can say basically roles we are assigning for groups, and inside the groups there will be so many users, and now these all user will get the access of this particular assets. This can be your data. So now if you want to give the permission to access this data to these entire people, you will be using role based. So you are creating a role and you are adding the permission in the role. This you will be learning in the next chapter when I will be teaching the IAM. Like the same here, the role, and these all are the permission. These two are the permission. And again, this role will be having a role group, means so many number of user will be here, and we'll assign them some assets. Assets you can keep it here as a services or resource in case of AWS. Mostly it used to be resources, right? I'll just tell you one example you can easily understand. Let's say we do have discretionary access control and we do have role based access control. What you want to access? That is the question. What do you want to access? You have created one user here as a user A. And here is one EC2 instance you have created. Now you want that this user A should have the access of EC2 service, then this is the discretionary access control. When you will go to RBAC, then by using EC2 instance service, you will create some instances. You will create some instances or instance. Now, who will be using this instance? Let's say you will create a role, right? You will create a role. And in the role, you will add a permission. Add a permission of what? EC2 instance. Now, wherever you will assign this role, either you can assign this role to any uh, user, or you can assign this role to any group, or you can assign this role to any other service also. So it is the role based access control, guys. This is how we are controlling the role base, right? And this role you can attach with the multiple user, not only this user. Let's start the lab. This lab is very simple. We'll go to security and we'll start with the data security, data protection. Lab number 278, guys. Lab number 278. We'll click here and here we'll configure the workspace. Student view. Start the lab. Guys, have you started the lab?
Yes, sir.
Yes, sir.
Not yet, sir.
I can check it also. Actually, today one of my wife friend was there, best friend. Her husband passed away in the early morning today. So from that time, different kind of fear came. But even though we are not going to stop our daily work, right? What we can do? This is the life.
Yes, sir.
One another day, This is the truth of life, everybody has to accept, right?
Yes, sir.
So many of you have started, as I can see here. Jaya Sai Krishna, Mayur Sankar, Geetika, Bhanu Prabhas, Charan. Perfect. So let's get into the lab. Here we'll click on AWS and we will go into the lab. See, before starting this lab, I will just explain these steps because we are going to follow the same steps. Other than these steps, if you follow here in this lab, it won't work. So it is our, weak part here, like we have to follow the steps. Now, here, the first thing is we are going to do the encryption and decryptions. For that, we have to create a KMS key, right? We will create a KMS key, and this KMS key we will be using further to encrypt the data, and by using the same key we will be able to decrypt the data. So here this is your steps that has given here to create the KMS key, and after that you will be configuring the file server. File server means there will be some file uh, specifically on the, means you will connect the machine, there you can create some file here as we are creating the files, and after that here you can encrypt, and here you can decrypt the data. This is what we have to do. Clear, guys?
Yes, sir.
So let's click on services and go back to security, identity and compliance. Here we will be getting the KMS, key management service. Or if you are not getting here, you can just click here and you can search KMS. Simple. You will open KMS. And remember, we are not going to do asymmetric. We will be doing symmetric only for understanding it. We'll click here to create a key, and symmetric key we are going to create. And the purpose of creating key is to encrypt and decrypt only. Next, here it is asking aliases. Let's see. Uh, Alias can be the name, you can say. You can just write the my KMS key as a name here. And in description, we can keep this key we are using for encrypting and decrypting, right?
Yes,
Now,
sir.
there is no tag, I guess. We will click on next. Now, basically, in AWS, once you will be learning the IAM, you will able to understand basically whenever we are using some services or resource, so we must have to provide, few permissions to that. So here some permissions has been added, and we have to search Oak Labs here under
Okay.
the permission. The permission has created for us, and one day we will create our own permission, right? So we will select this Oak Labs here, search Oak Labs and select Oak Labs here and click on next. And second, key user, it again has been created by the same name, Oak Labs. You will come to know all these things once the next chapter, the IAM, will start. You will come to know what is this permissions and other stuff. Easily you will be able to do all these things. For now you can understand this is permission of using this key with the data, means the data can be in your EC2 instance or it can be in S3. Next, and the policy, whatever it is coming, we have to just use the same policy, right? And we have to just click on next, and we have to create this key. We have to create this key. That's it. We have created it, and please confirm once you are done with the
Yes, sir.
done?
Yes, sir.
Done, sir.
Yes, sir. Done, sir.
Done,
Done,
sir.
sir.
Good. So next time once we will come, we will click on this KMS key and we need this ARN, Amazon resource name and number, you can say Amazon resource number. So you will copy this next time once we will be using it. So we'll come into KMS and we will copy this when we need the ARN of it. We can go back. Now where to find out? You can go to you can go to customer managed key. Here you can see the KMS key. Okay. Now you will go back to EC2 instance and you will connect your machine. You will connect your machine. So here it has been given how to connect the machine. So first of all, you need to remember one thing. There is one Linux machine which is running here, right? This is the file server one Linux machine which is running. What you can do is you can connect this Linux machine. Directly you can connect. No need of putty and all. It can connect from the browser. To make this work very faster, this permission has added to you. They have given permission.
Yes.
Okay, they are telling to connect it by using session manager. All right.
Session manager. Yes, sir. I
Yeah,
have to
we will
connect.
click on session manager, second option, and we will connect. Because the other permission we have added here, so that session manager, through the session manager we will be able to connect. I'll tell you once in the next IAM only, there are all the chapters, all the things will be coming of permissions related. Now now you need to understand one thing, guys. Once I have connected this machine, now I want to use AWS by using CLI. So I have told you we have to download the CLI. We have to download the AWS CLI. Got it?
Yes, sir.
But what is the best part here? The best part here is we are using Amazon Linux 2 AMI. This is Amazon Linux AMI. In Amazon Linux AMI, the AWS CLI is pre-installed. Rather than this Amazon Linux, you cannot get AWS CLI as a pre-install. This is of Amazon. This is of Amazon. So it is pre-installed. It is available here, right? If you will create further Linux machine of Amazon Linux, you will be getting the same again. Got it?
Yes, sir.
So here we are not supposed to create the download the CLI. So if we need to verify CLI has been installed or not, you will write AWS space hyphen hyphen version. You will be able to check whether AWS is there or not. CLI is there. Got it? CLI is there. Now we will try to log in. Now we'll try to log in. So let's try to log in. First of all, let's see what reason we are going to use, or we will be seeing that time only. This step is little bit complicated, so please make sure to listen it carefully and perform it carefully. The the command which we are going to use here to log in into AWS account is AWS configure, right? AWS configure. I'll hit enter. What it is asking? AWS access key ID, right? I'll give
Yes, sir.
one here. Why? Because I don't know the access key for now. This will store in a file. In the same file, we will change later on. And enter. It is asking secret access key. Again, I'll keep one. enter. Now it is asking the default region name. So you can see here, when it is asking default region name, it is telling go to AWS detail and try to find out what is the reason. And this reason will be, I guess, common to everybody. And the reason is US West 2.
US West 2.
So here we will write US hyphen West hyphen 2. Enter. Now the output format, by default it used to be JSON. Let's write JSON. It will give entire output. If we create something or if we do something, it will give us the output into JSON format. This is what we have done. Now these entire info or information will store as a credential in a file, and what we will do is we will go back to this detail page. Can you see this option? AWS CLI show. Can you see this text, guys, here?
Yes, sir.
So this is the text. Now here we can see this is what we have to replace for accessing the account. If you go back here, if you do ls here, array clear up the screen and just write cd here and then do ls. There is nothing. Do not forget to write cd. I wrote cd, I did ls, nothing is coming. I want to check hidden file of it. So I'm getting dot double dot aws. Inside dot aws directory, see the top three are directory, bottom three are file. And you know that these files we are using for the starting of your Linux machine. And .aws is the directory. In this directory, the credential has been stored. So we will go to the .aws, change directory cd space .aws. Now we came into .aws. If I list now, this credential is coming here. Credential is coming, guys.
Yes, sir.
Yes, sir.
Here if you write nano space credential, you can see this is what we have stored, right? This is what we have used. So you have
Yes,
to replace this text. You have to replace this text by keeping this new text. By keeping this new text, which is here, including default and till the last. You have to copy this and you have to paste here. You have to paste here. Okay. Once you'll paste, Control X Y enter, you will pass the credential proper. Control X Y enter. Now you can also verify by using cat command the same credential file. This is what we have modified. This is the same text which has been given here. It means that this is the entire credential to enter into the, this is the entire credential which contain access ID, access key, and it is giving us the session token. Means whatever the AWS account which we are using right now, that session for 1 hour which we are using, it has given everything for us for 1 hour. Now till here it is clear to everybody?
yes, sir.
It means now we have logged into the AWS. Now we have logged in into the AWS. Now we have to install AWS Encryption CLI. You have to install and you have to set the path. So you can see here, if you are using CLI, so you will be using SDK for encrypting it. So you can just copy this command, both line together, and you can paste in your machine. And you can run this command. Okay. So it will install the SDK of encryption. Now easily, once if you need to encrypt or decrypt, you can just write encrypt decrypt, it will encrypt and decrypt. That's it. Now the last, let's say we are creating some file here, secret 1, secret 2, secret 3, like that. So I'll be creating only one file. Let's write here touch command, or we know nano, so we can use nano space secret file dot txt, or the same name will write nano space, what is the name of file,
Secret.
secret1.txt, right? So I'll just write secret1.txt, and I'll write some text here. Let's say this is the password of my Facebook, and the password is 6478328 at the rate 124 DFZ. This is the password of my Facebook. This is not the password of my Facebook. Honestly, I'm telling you all, do not try. Okay. So here I'll save it, Control X, Y, enter. So I just written to show you the sensitiveness of that file. So if you use cat command and if you see the secret file, it is straight away showing this is the password of my Facebook. Now we are going to encrypt the same. So the last command here which we are going to encrypt here is, before encrypting, where you want to store that encrypted file. So for that, it is telling us to create one output folder also. So we can just simply write mkdir output. So your entire encrypted file will store into the output. Now here you have to assign the key. Now before before encrypting, you have to assign a key. So you have to write key ARN. See how to write key ARN. Key ARN, A will be capital, key ARN is equal to, now you will go back to the KMS again and you will copy the ARN of it. So we'll open and we'll copy this ARN and we'll bring here and we'll paste it. So this will take the ARN. Now if you see this command, guys, so this is the syntax. This is the syntax of using this command. So the command will be AWS hyphen encryption hyphen CLI space hyphen hyphen encrypt. We are going to encrypt space slash new line hyphen hyphen input. What input we are taking? secret1.txt as an input we are taking for encrypting it. Wrapping keys will be your attribute, that this will tell, this command tell the this what do we say, wrapping keys will say
So, hello.
command to use the KMS key, right? This will say, wrapping keys will say to use the KRN, sorry, K key ARN. Yes, Deepak.
So, can you please repeat the TRN step once?
See key ARN, are you able to see this key ARN?
Yes, sir. In a parenthesis, we supposed to add the error number.
Yeah, so for that you have to go back to KMS, search KMS here
Yes, sir.
and go back to customer managed key, left side, and open your keys, and this is the ARN. You have to copy and you have to write like this, KARN equal to, and after that you can paste it here. Got it?
Okay. Yes, sir.
So see what exactly this syntax is telling us to how to encrypt. We will be using the command AWS encryption CLI hyphen hyphen encrypt. This will say we are encrypting. Input will say what file we are encrypting. Wrapping keys will say what key we are using to encrypt. Now metadata will say Metadata output parameter is used to specify a text file for the metadata about the encryption operation. So metadata means how the encryption is happening, what algorithms are getting used. For entire these operations we are using the metadata. Metadata means the details of that operation. And then encryption context purpose. The purpose of encryption is test, just for testing purpose we are doing. And then we do have commitment policy. The commitment policy parameter is used to specify that the key commitment security features should be used to encrypt and decrypt. So it is telling whatever the key we are giving here, it should use to encrypt and decrypt. And at the end, output will store into the output directory. I hope it is clear. The command is clear to you all.
Yes, sir.
So in one time you cannot remember, while doing it, you can remember. Basically this hyphen hyphen all these things you can add in any series. So it is not, mandatory. Like you need to write this line perfectly correct. And after that, these things you can keep it up and down. It will take as it is, right? So for now, we will just copy this command straight away, all command, and we will paste here in our machine so that it will encrypt the, see, this is the command. Simply once I let enter, cryptography deprecation warning, Python 3.7 is no longer supported by the Python core team and support. Okay, let's see the output, whether output is coming or not.
Not coming.
Not coming.
Yes.
uh, mhm. File name is correct, file name is also correct. uh, So why it is not working? Is it working for anyone, guys?
No, sir.
See, if you can check it out by giving the this command also, echo dollar with the question mark. If it is coming 0, it means that command has been executed. If it will give some number, it means that it is not executed.
Sir, I'm
So
getting a pop-up called command not found, sir. After the pasting the
it
that
means
stick.
you did not install this command proper. This command, this one, 29th number, pip.
Okay, sir.
Let me run one more time here. The sudo yum update once hyphen y. It is updated one only. Hmm. Why it is coming like this? Let's ask to the chat GPT once. Arey yaar, this is the command.
That is the problem of output only, sir. Directory.
Is it?
Yes, sir.
So our directory is Mm, right now I'm into okay. Sorry.
Yes, sir. You remove that one.
Uh, Let me go to my directory and I was into .aws, right?
Yes, sir.
So uh, this is my present working directory. If let's do it from starting in the sense right now there is right now we are into /home/ssm user, and I have connected and I forgot to come from that directory. So now let's create the file here called nano space secret 1.txt. Enter. Just write password. This is the password. Control X, Y, enter. Now this file is here, and we have to create one directory here by the name of output. Okay, now we'll paste the command. Let's check it. It's saying the same.
Sir,
Hmm.
before installing the command, we have that command, right, sir? Pip install.
Uh,
Before that, I got that zero number, sir. But I got what command not found.
this pip you are saying,
Yes, sir. Before that, I got zero, sir.
this is not running, right?
Yes, sir.
Let's rerun it again. There is some changes it seems into, the already satisfied it is saying. Now export the path is also fine. Now once after running this we will create this. We will be moving as it has been given through this command only. Okay, top secret we have created. Output is already there. Key ARN we will try to add one more time. Key ARN. If it is not working for anyone, it means that there is a problem
Sir,
into.
I got it, sir.
You got it?
Yes, sir.
Very good.
The
So
number is zero, sir.
very good. It means now we will also get it. Okay. So we have done this, and now we will try to copy this command again, and we will try to paste it here to check it whether no. Dollar question mark enter.
Sir, it's echo dollar
Echo,
question mark.
echo dollars.
Echo dollar question mark enter. Ah, wow, it has been done, guys. It has been encrypted. You can see this in output. Secret1.text.encrypted it is coming. So if I'll bring you to output directory, and if you do ls here, it is coming secret1.txt.encrypted. And if you just
Yes,
see
sir.
cat command, and if you just check it out, this will come into Chinese language or in different text. See, this is encrypted. Got it?
Yes, sir.
And now if you need to decrypt it, Now if you need to decrypt it, same cd output, you can check it out here. For decrypting it, we have to be into output, and after that we can run this command to decrypt it out, and this will straight away, this will decrypt it. Let's do ls. See, it is saying some warning and all, but it is decrypting and encrypting. Now if you see this secret1.txt cat space secret one dot encrypted dot decrypted, so this will show the top secret, right? Working, guys?
Yes, sir.
Sir, can you show it once again, sir? I'm also doing it, but it's not working for me, sir.
See, this is the command, right? Let's
Yes,
say
sir.
if just check it out one thing, where is right now your, what is your present working directory? So we are into output. What we will do is we will go back from output first. What is present working directory now? SSL. Wherever you are, just write cd enter, you will come into the same place. Okay,
Yes, sir.
after doing this you can create a file here. Let's say any file name. Let's say I am just writing here nano space top file dot txt enter, and here I'm writing top secret file, this is some number and this is what, I'll save it, enter. Now the file is here. uh, the file name is top file dot txt. Remaining the secret1.txt, secret2, secret3, secret, this secret 1 2 3 we can delete by writing rm space hyphen rf space secret. Here we can keep a question mark and then dot txt. It will only delete the secret 1, secret 2, secret 3. Okay, now you do ls again, only top file output metadata is there, it is enough to run the command. Now this is your command. So here
This is decrypt
this
command.
is decrypt, this is encrypt command, right?
Yes, sir.
So what will I do is I'll just paste this command in the notepad first, and I'll change the name of file. Why? Because if you will do it there, it may show some issue. Top, what was the name of file? Top file.txt, right?
Yes, sir.
So here I'll write top file.txt. This is the file, and I'll just uh, copy it again and I'll run it here. Enter. Now I'll just ls the output directory. See, top file encrypted is coming, top file txt dot encrypted, and if you will use cat here to see the same file, top file, sorry, not here, we will go to output first, and here we can do the cat top file dot encrypted. It is encrypted completely, we cannot see that text. And now we will just clear up the screen, and now we will decrypt from here itself. So the decryption command is here, and you can just copy this and you can again paste into the notepad, and the file name is top top what file, guys? Top file.txt dot encrypted it was. We'll
Yes,
copy
sir.
this and we'll paste it here again. It will decrypt now. Do ls. It is decrypted now, and if you see the cat in top decrypted file, if you see, this is what the file we have made it already. Understand?